Hello all. Still struggling with camera angles, but I wanted you to be able to see the parts and that are associated with this work we're going to do today. So as I mentioned at the end of a previous video, our next project is to replace the stepper motors and stepper motor drivers on the CNC machine with closed loop servo motors, and these motors from Stepper Online have an integrated driver and encoder for the feedback or the closed loop part of the description. And what we need to do is a bunch of mechanical work, a little bit of wiring. We need to replace the couplings because the shaft on this is 8 millimeters versus 1/4 inch. And if you want to take a look here, this is the integrated driver. It has separate power connection. It has your step and direction inputs. It has an alarm output. And it also has a connection for a serial cable because this thing is software configurable. You can also configure settings with the dip switches, but if you leave them all off, then you can configure it in software. And there's quite a bit more settings that can be done in software than it can be with the dip switches. One of the things that you can do is you can run an auto calibration where the motors will drive back and forth a number of times and set like speed advance settings and PID loops and things like that to try and make it as positioning accurate as possible. And so we're going to try and do that. I know a few others who have tried that with the software that is recommended to be used with this have not been able to get that feature to work. So, you know, I don't have super high hopes, but we're going to try. There's our serial cable that comes with it. It's got the little custom plug-in for this side. And other little connectors for wiring. Let's see, what else have we got here? Already showed you the couplings. Then on the 6-pack controller that we purchased through Tindy from Bart Dring, we used these TMC 5160 servo or stepper motor drivers. Now these things, I chose them for two reasons. One is that the old controller said it had 5160s integrated into the board. I may take that thing apart and try and verify that. But the other reason was because they claimed to be able to output as much as 5 amps. And so the motors, the steppers that were included with the kit that I built said they peaked at 3 amps. So I thought it wouldn't be bad to have a little bit of headroom on that. But what I've found over time, and a lot of frustration, is that I believe it's the drivers are going into an error, and the motor goes offline. And sometimes it's, more often than not, it was Y0 that would go offline. So unfortunately, with 2 motors on the Y-axis, the other motor's still going and starts racking the gantry. And oftentimes more than one motor would go offline. And so it's very, very frustrating. And I haven't had a lot of success. I have made some things that came out okay, smaller things with not a lot of axis movement seem to make it through the machining. But when I was making larger things, especially if the machine was moving more than one axis at a time, it seemed like more often than not, the Y0 motor went offline. And I think, or at least what I've learned from, you know, forum discussions with Bart and his partner that are, all, you know, the ones answering the vast majority of the questions, it has something to do with how these motor drivers seem to spike and require, you know, instantaneous, a lot of amps, and they don't feel that that a switching DC power supply can make it through those transients. And you know, if they're right, that it kind of makes sense. So I had wanted, and even before I bought the machine, my plan was to eventually upgrade to these, I thought closed loop steppers, but now the more I read, I think, you know, the choice for the closed loop servos was better. So I had planned to do it eventually anyway. I was hoping eventually would have been a few more years from now, but it isn't. So, you know, we ordered these. We ordered the motors from Stepper Online. We ordered these couplings through Amazon. And by we, I mean me. And, you know, Bart sent us these little chips that are meant to replace the onboard servos or stepper drivers, and they're basically just like pass-throughs. They pass the signal through to the pins because our driver is on the servo now. And unfortunately, I understand why he sells them unassembled like this, because he's trying to keep the price low. He sold me all 6 of these for $15, including shipping, which is ridiculous. Like, you can't even get lunch for $15. But we have to solder them all together, and it's not going to be hard, but it's just going to be a pain. So that's the next step. I may film a little bit of the soldering just for anybody who wants to see it, but this isn't like really highly technical soldering. So we're gonna do all that, assemble all these. I only need 4, but I'm gonna put all 6 of them together and just populate the slots, maybe for future use. So we'll see. I'm gonna heat up the soldering iron and we'll film a little of that. And then the next step will be taking the steppers off, getting the couplings rearranged. We're gonna have to pull new wires because we need 5. We need a step, a direction, 2 wires for 48 volt power, and of course the common signal for the step and direction. So we need 5 wires. Okay, so there's 2 sets of 8 pins on each of these, and then there's 1 set of 3 pins, which is recommended because they're in the middle, I guess. It's recommended you do those first. I don't own a proper soldering station, so I'm only going to film 1 of these because I'm not sure you should use me as a reference for doing this kind of thing. But what I think I've proven here is that if there's a will, there's a way. I just got a big glob of solder on there, but you know, hopefully that'll unglob itself some kind of how. All right. Nope, it didn't. There we go. And the last one. And I don't have anything to properly hold these either. There we go. All right. So, you know, pin by pin, it's tedious and time consuming. I would have paid for these to be assembled. Okay, so what has to happen next? Here you can see the new servo, the new power supply, and the new coupling. These motors, 4 of them, need to come off, and these need to go on. These are, I don't know, they're a lot heavier. I may need to make supporting brackets just for the weight. You know, this vertical one up here, I guess maybe won't be as big a deal, but we'll see. Boy, our autofocus is not working that well today, is it? All right. The next thing that I saw that may be a little bit of a problem is, and I thought I double checked this, the coupling length is not the same. So the new coupling is shorter, but that may be okay. Hopefully there's enough overlap to where that'll work out. And so what I'm gonna do, I'm gonna take you in here. It's a little bit dark, but the motor connectors are up top there. We need to unwire all that and pull that wire out. And we're gonna need to pull new wire in, which will be a 5 conductor. 3 conductors will go up here, and then 2 will go down here to the new power supply, which is going to sit right here, like this. So those will have to wrap around. Those wires that will have to be stripped way back so that they can wrap around up this way, down here, and around to the bottom of the power supply. It's going to be interesting. It's a little bit of fiddly stuff to get right, and what I want to kind of do is just really take my time, and it's so tight back here that I can't really film all that, but I'll kind of bring you back when things are getting tidied up, and we'll see how it looks. Okay, gang. So we're working on the CNC machine. We spoke earlier, and one of the things that's going on is I had a lot of trouble with these motors, these servo motors, and to be honest, I wasn't entirely certain whether it was the servo motor or the servo motor drivers. I had some conflicting information back from the FluidNC project, and I think, you know, we were just saying the same thing with different words and misunderstanding one another. But so what happened, as it turns out, I had always intended to replace the servo motors with closed loop devices, or the stepper motors. These are steppers, these are servos. I had always intended to replace them with closed loop versions anyway. So what's gone on is that I've purchased 4 of these closed loop servo motors, and I'm replacing the open loop steppers. As you can see, they're quite a bit larger, and I think quite a bit heavier. So I'm a little concerned mostly about the Z-axis, because the fact that the motor has to not only move the spindle up and down and the axis itself, but it has to drive its own weight up and down as well. So I guess we'll see how that goes. Even though these motors are larger, they're not rated for higher torque than what these were. And of course, you know, sometimes it's difficult to believe the ratings that some of these Chinese manufacturers give their devices, because they tend to be very optimistic. So, so that's something that we'll see. And so I spent most of the day yesterday running and terminating the new wires. I needed, at a minimum, I needed 5 wires at each servo whereas I only needed 4 wires at the steppers. It would be nice to have 2 more wires, because these servos have an alarm output that will go into alarm if they realize that they're not reaching a position that they should be in. So that's the whole point of the closed loop part of the system. So eventually I'll either replace the wiring again with a cable that has at least 7 wires and maybe 8 as a spare, or I will run another pair to each motor. I'm not sure what's makes the most sense. Probably run the other pair would be less wasteful. I hate to waste the wire because I don't really have any other use for it. The other thing that kind of went on is the old or original couplings that coupled the 1/4-inch shaft of the motor to the ball screw. I had, before I took them off, I had thought that the coupling went right onto the and fastened right onto the screw itself, but as it turns out, the manufacturer had turned down the end of the ball screw to 8 millimeters. So so my original coupling purchase was an 8 millimeter to 12 millimeter, and when I took the old motor off, I realized that that wasn't going to work. So then I ordered, or I thought I ordered 8 millimeter by 8 millimeter couplings, and when they arrived, they were 7 by 13. And it just turns out the 7 by 13 coupling button was right next to the 8 by 8, and I swear I pushed the right button, but I obviously did not, because my order, when I went back and looked at the order, it even says 7 to 13. So somehow I missed that when I reviewed the order. So I ordered the wrong thing, so now I've ordered the right thing. Maybe I ordered the wrong one again. Anyway, soon those should be in, and we will get the couplings installed, get the last couple of motors installed. I have a little jumper that I need to jump from here to here, just to give the signals a reference. On the control board, there's only one reference pin anyway, so there's no point in running 2 wires from the control board because there's only one pin to connect them to. So we will jumper the reference from here to here. The servo motors have a step pin and a direction pin and the reference. These 2 wires up here are the power wires. They are coming from, and this is a decision I have to make, and I'm probably going to do some trials and see what works best. But I purchased a 48 volt power supply to power these new servos, and it has 3 positives and 3 negative kind of outputs on it. I'm sure they're all bussed back together to the same spot, but I thought I would like to only connect one motor to each set of supplies. So there's only 3, I have 4 motors. The old power supply, which was a 24 volt DC power supply, was powering the control board and all 4 motors, the old steppers. So these motors can be powered from, I think it says 12 to 50 volts. So what I'm going to do, I think because the control board only needs about an amp or an amp and a half, they say, I am going to use the 24 volt DC power supply, which should have about 8 or 9 amps left, to power just the Z-axis and the control board. And I'm hoping that there's enough amp headroom for this thing to be able to drive this weight up and down. And then the other 3 motors will all come off the 48 volt DC power supply. And we'll kind of, run the machine around and check it and see how that goes. It's been quite a while that it's been less than optimal. You know, we did that video, but it's been over a year ago now, where I was bragging about the Bart Dring's 6-pack controller, and I'm still super happy with his 6-pack controller, even though I haven't hardly used it. I think it's a great design, it's a great device. He's a brilliant man, and there's a lot of good things about it. What it exposed for me was that I didn't really know that much about the machine, and especially the electronics. The controller that it came with, they say, in fact, I'm going to grab it real quick. So this is the controller it came with. It's the Sparks Concepts X Pro V5. Now they claim that this had the same stepper drivers in it as the ones that I purchased to initially run in Bart's controller. And that's one of the reasons why I chose those, because supposedly they were in this one and they worked. I did not have the issues with this that I had with Bart's control. Now I don't know what might be the difference between the two. One thing is that this does have a big heatsink and a cooling fan on it, which Bart's does not. So maybe that's the difference. Maybe the stepper drivers were going offline because they were getting too hot. But whenever they do have heat sinks on them. And whenever I would put my hand on them, you know, after one went offline, it was never hot. So I don't know, you know, were they getting hot? I have no idea. So looking at this, I can't confirm or deny that this has the same drivers in it. I think they may be underneath this heatsink. So maybe that is how they were able to get those drivers to work so well, or at least they worked well for me. Maybe they were applying active cooling to them from the beginning. Again, I can't tell. I'm probably going to repurpose this to build a little, and it's going to be a small automated plasma machine. I have the motors, I have this. I have some other parts and pieces that I've replaced over the couple of years that I've owned this. So I have a bunch of stuff that I could repurpose. So maybe, you know, maybe that's the thing to do, is to just you know, reuse these pieces with that. So a lot of babbling, a lot of nonsense. Hey gang, so here are some administrative things that we need to change in our FluidNC YAML file, the config file that it uses to know how your machine is set up. So we've removed the 5160 stepper motor drivers, and if you look here at the configuration, this is the kind of the configuration that you would have for these stepper motor drivers. There's a lot of settings in it, much different, because now since we have external drivers, the settings are all done in the external drivers. No settings are done in the config file. So the standard stepper motor config file looks like this. So these three settings do exist already, but they're the only three that we need now. So let's take a quick look. Again, just an administrative kind of cleanup thing. Here is our original
YAML file. And you can see here TMC 5160 and all these settings. All we need now, we need to change this name, and we need these three things. So here's my updated file, standard stepper, and I left the pins the same, except for the disable pin, which the new servo motors do not have an enable, or as it's called here, a disable function. They're always enabled if they're powered. So that's how these work from Stepper Online. So that's kind of it for this. We'll move into the next.
Okay, gang. So we're back again working on the CNC machine, and I kind of wanted to go through and show you the pieces that have been replaced. So first of all, let me get this thing tracking. The old motors, stepper motors, have been replaced for servo motors. And it's not tracking. Hold on. Now it's tracking. Okay, so for the servo motors are here. The wiring is a little bit different. The servo motors get power anywhere from, I think they said 12 to 50 volts DC. The stepper motors get a pulse of power. The stepper motors get a pulse of power, and they were 24 volts DC. The other thing that the servo motors have is they have a direction pin and a step pin. So it's sort of the same. They still take steps, but they don't step pulse the power. So anyway, these have been replaced. The next thing that's been replaced is these, the original stepper drivers, which was a TMC 5160 from Big Tree Tech, have been replaced with these pass-through boards, which just pass through the step, the direction, and the enable pin. Step, direction, enable, and a neutral. So the new servo motors don't have an enable disable function, so they don't use that pin, but anyway, that's what these boards provide. Additionally, the old motors were quarter-inch shafts. The new motors are 8mm shafts. So the couplings have been replaced, and I don't know if I can show you a coupling, but maybe over here. Let's come over this way, and we'll show you a coupling. Unfortunately, this thing, I think, is tracking my face. Hello, down here. So here is the new coupling. New coupling. All right. And the new, so the servo motors have an integrated driver, so the intelligence is on the servo motor, and there's also an encoder which gives the servo driver a feedback of travel information. So if it gets, 632 steps, it checks to make sure it actually made 632 steps. So assuming the coupling doesn't slip, which will tighten them down really well, assuming the coupling doesn't slip, it'll hopefully be more accurate in that way. So let's go back this way. And this is my first time using this new camera gimbal, so bear with me. I give up. Okay. What else was replaced? So those pieces are going to be replaced. The servo motors were replaced. Of course, new wiring was run because now we need a minimum of 5 wires. Hot and neutral for the DC power supply, step, direction, and common for those pins. So new wires were run and connected. The next step is to put in the pass-through, the little pass-through chips I showed you, and we have to reset the config file to not look for the TMC 5160 drivers. Now it's just going to pass the step and direction through to the external servo drivers, which are mounted on the motor itself. So I'm going to get the computer out, and we have to redo the config file, and then we'll come back and hopefully run the machine a little bit and see how it goes. The other thing that these servo motors have is they have a communication cable which can be hooked up to your computer, and you can do some tuning on their performance. So they can take into account inertia and acceleration and things like that, and how that affects the motor and how accurately it drives. So not sure how that's going to go, but we're going to try it and see.
Okay, we're getting our feet wet tuning the x-axis, and as you can see here, we're looking at the graph after I've driven the axis back and forth, and we have a position error of 5,840 steps. That seems like a lot. You know, we're 4,000 steps per revolution. So I don't understand. We can't be a whole revolution behind. So I'm not really sure how this works, but I watched a video of a gentleman who tuned his motors, different brand motors, different software, but he used this setting very similar to this, which talked about the stiffness of the motor, and he was able to change his quite a bit in order to improve the position error. Now, if I change this above 11, we get a screaming noise, which is pretty undesirable, and I'll let you listen to it here in just a moment. I can try changing it to 12 and see. Yeah, see, that's not good. So I changed it back to 11, and of course it stops screaming or whining. The other parameter that this other gentleman changed that made the most improvement was some sort of feed forward setting. I can't remember exactly what it was called, but that's what kind of leads me to believe that I should attempt to, change this feed forward gain in order to improve the stepping performance, the error of steps performance wise. So we're also going to try changing this ratio of inertia, and I've upped it to 1,000. And what we'll do is we'll do a test to see how that goes. And as you can see, really made no difference whatsoever. We're still at 5,840 steps behind. So once again, still 5,840 steps behind. I did attempt to put this setting up to 1500. Oh, well, and I'm attempting right now to put it up to 2000, and it's screaming again. So we turned it back down to 1000 and it stopped screaming. We're going to attempt to turn it up to 15. Nope. We turned it back to 800, and I believe I did try 1500, which it even still screamed at 1500, so that's why we put it back to 800. And this is where we wind up leaving this setting. So here I'm looking at this feed forward gain setting again, and I wanted to just try incrementally increasing it. But as you'll see, when I change the number, it goes right back to 300, which is the default. So I'm unable to raise it up. I don't believe I tried lowering it down, but I'm pretty sure it would not have allowed that either. And in the next couple of clips, we'll find out why, and we will find out that this setting is a super valuable setting to be able to adjust here. Okay, so what I'm trying to accomplish here is to shorten this video because it's gotten to be way too long. And what I've done is I've set the speed to ×2, and I want to try and describe with a voiceover what's going on. And you'll see that you know, my voice is not going to line up with my mouth. And if I had, you know, it to do over again, I wouldn't have put my face on here. So we are looking at the parameter ratio of inertia. The default is 250. All four of my motors were set to 800 when I received them. So again, not sure why they wouldn't be a default, but they weren't. The next parameter that we wanted to attempt to change was this velocity feed forward parameter, which on another gentleman's video, there was a setting named very similar to this that he changed and was able to get quite a good improvement out of. Now you'll see here I'm having to change the real-time auto gain tuning to 0, which disables it. That will then allow me to set this parameter to a new value. And of course 1000 is the highest allowable value. And on the x-axis, which I've already finished tuning, you know, 1000 was where we set it and where we wound up leaving it. Okay, so let's see how that improved the performance. We're still oscillating about ±2 microsteps. We'll drive the axis back and forth a little bit, and it looks like we've gotten a pretty decent improvement from changing that parameter. So we're down to about, you know, roughly ±40 or even a bit less with some spikes. So that's not terrible. The machine stiffness, which we had at 12 and the default is 11. So we're going to bring that back down to 11 and see how that does. You know, we only want to look at the position error on this chart. So unfortunately you have to reset those settings every single time. Looks like our spikes are a tiny bit lower and our mean offset is about the same, maybe a tiny bit less. So, you know, stiffness at 11 is probably where we want to keep it. I guess the next parameter that we attempted to adjust was this first torque limit. On the x-axis, we wound up bringing it up to 500, so we're going to try that here. See how that does. And you know, it's kind of a mixed result. It looks like you know, we had a bit of a negative effect. Our spikes are higher. Our average offset is about the same, maybe a tiny bit higher. So, you know, maybe that setting wasn't the best. So back down to 300, and want to see if, you know, if the results go back, you know, to the way they were when we change it back. And guess what? It didn't. It looks like we made it worse and it stayed worse, even though we reset the setting. So that's unfortunate and makes things a bit more difficult to try and figure out. We're looking at first position loop gain. Default was 320, it was set at 390. On the x-axis we set it up to 3000, so we're trying that again. And again, I apologize, I'm really just trying to make this video shorter. So our idle oscillations, we're not running the machine, well, now we are, but our idle oscillations were higher. Seems like the bulk of the average error is better, or at least a little better, but the spikes are higher. So sometimes it's hard to, you know, is this a better result or not? And how important are these short-lived spikes that we're seeing? Again, it would be nice to have more direction from the vendor, but we don't. The next thing I was looking at is this second time constant velocity loop. And being a time constant, this kind of makes me believe it's some sort of, you know, integration of error over time. It's set at 10,000 tenths of a millisecond, which is it is 1 second. So setting it to 600 as we did on the x-axis, and we'll run a test. Idle oscillations is about the same. Overall oscillations looks a little bit higher. So we'll go back and set that back and see what it does. And here I was just, you know, wondering, should I try and save each of these graphs so I could compare them later? Looks like the only file format they have is CSV. I guess that could be looked at in Excel or something like that. It just seems like an awful lot of effort to do, so I chose not to. So we're going to bump that back up to 10,000 and see, because it was a bit unclear as to whether we made an improvement or we made it worse. So we're going to run it again. And I think, for my part, I think that this is better than it was at 600. So we're going to try to put it somewhere in the middle, between 600 and 10,000. Looks like we chose 3,000. And we'll run the test again. And for whatever reason, I keep bouncing back and forth between yellow and red. We'll run the test again. Looks like idle oscillations went up a little bit, again, for whatever reason. And 3,000 seems pretty good. The thing that can be deceiving is when the scale changes automatically. So that can make it a little bit trickier to understand whether you're making progress or about the same or worse. So you gotta kind of keep a keen eye out for what that does and the overall effect. All right, so we also changed the torque feed forward gain on the x-axis, so we're going to do that again here. We set it to 400, so in the interest of time savings, I'm using values that I know worked before. That doesn't mean they'd work again, but just trying to save, get the video a bit shorter. It's already much longer than I'd like it to be. So, okay, this looks like a pretty good improvement. Some spikes around low to mid 40s, and the bulk of the error, 8 to 16. The other thing we did change was the feed forward filter. I believe we made that 50 on the x-axis, so we're going to try that again. Run our test. Drive the axes back and forth. That looks like an improvement to me. But again, you gotta really watch when the scaling auto adjusts. So it's something to keep an eye on when you're doing this. All right, what else did we look at here? I believe the last thing we did. So these two parameters. First filter of velocity detection and second filter of velocity detection default at 15, but we're set at 7. I have not adjusted these yet. So in the interest of time, I'm going to change them both to 15, and I believe we left the x-axis at 15. Run a quick test. And pardon me, I've got a little bit of a sniffle going on here. I'm not sure if it's pollen or what it is. So that looks like a little bit of an improvement. Outlying spikes around 30, but the bulk of the error, below 16 for sure, and even maybe closer to, 8 to 12. So that's pretty good. I think that's as good as we got the x-axis to be. I believe there is one more parameter though here, and this is called a positional command smoothing. And we did change that on X. We're going to change it again here. We brought it up to 10, so we're going to try that and see how that goes. So I think at this point the axis was oscillating even quite a bit, even in at idle. It was noticeable to the feel, like if you put your finger on it, you could feel it. So not sure what caused that, but seems like these things are a bit temperamental.